Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Reinis and Land Science. Before we get started with the webinar today, I have just a couple administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will focus on construction quality control during vapor intrusion mitigation system installation. With that, I'd like to introduce our presenters for today. We are pleased to have with us Dr. Sigrida Reinis, Senior Associate at Langan Engineering and Environmental Services. Dr. Sigrida Reinis has over 30 years of design and construction oversight experience. She is the technical leader of the gas and vapor intrusion mitigation and monitoring practice for Langan in California, supporting projects ranging from quarter-acre brownfield redevelopments for affordable housing to landfill redevelopments for multi-tower office campuses. She also leads the probabilistic cost estimating and decision analysis practice for Langan, and has provided peer review services, litigation support, and expert witness services for both construction and environmental engineering cases. We're also pleased to have with us today Nick Mjolsness, Senior Technical Sales Manager at Land Science. Nick Mjolsness provides technical support in the design and installation of TerraShield, NitroSeal, MonoShield, and RetroCoat vapor mitigation systems, and also educates the environmental community on advancements in vapor intrusion barrier technology, implementation, and quality control by making presentations to environmental firms, regulatory agencies, and developers. He is a technical sales expert with 11 years of experience in vapor intrusion mitigation, specializing in assisting clients with solutions for the redevelopment of brownfield properties. All right, that concludes our introduction. So now I will hand things over to Dr. Sigrida Reinis to get us started.
All right, thank you very much. Thank you very much to folks at Land Science for inviting me to present this webinar, and I'm very pleased to do so. So yes, the topic for today is broadly construction quality control, or CQA, for vapor mitigation system installation. And I say and beyond because we'll also go into what can happen with these systems post-construction. All right, so just a quick overview of the kind of topics that I'll cover today. So first, just the motivation. First of all, why are we even just talking about construction quality assurance? Then go through a variety of what I'll call flaw types and timing, what the potential consequences are of these shortcomings, and then quite a few project examples, and at the end, some just tips for success. And at the outset, I just want to make very clear that we as design professionals can and do specify different membrane types based on a variety of considerations. These membranes can be provided by a variety of manufacturers, and design professionals select these membranes just based on site conditions and the perceived suitability of a certain product to those conditions. And the project examples that are discussed in this presentation represent design or installation shortcomings and not product failures. So first, why talk about construction quality assurance? Well, as design professionals, we put a lot of thought and care into the design. We select an engineered membrane based on the type and location of the site. Is it a brownfield? Is it a landfill? That type of thing. Also, the type of structural foundation. We here in the San Francisco Bay Area, a lot of our structures are supported on piles where ground motion or just general settlement is expected. And then, of course, also on the nature and degree of environmental impact at the site. We also coordinate with other disciplines on the design team, among them the architect, the structural engineer, mechanical, electrical, and plumbing, the landscape architect, and possibly others. We also might end up coordinating with the general contractor and the membrane applicator on, for example, construction sequencing. There could be an elevator pit that's challenging to, if you will, put together. And so we need to coordinate and work with them to come up with design details that mesh with the planned sequence of construction. We also generally reach out to the membrane manufacturer for assistance with some of those specialized details, or perhaps just ask them to review our drawing set so that everything is in sync with their preferred methods of installation, etc. And of course, in the end, we also then provide the full set of design drawings and specifications to the team. And so after all of that thought and care has gone into the design, I would say that same level of care needs to then go into the systems installation. And the philosophy here is trust but verify. We do, of course, expect contractors to do their best, and installers, of course, do their best. But sometimes things go a little bit sideways. And so as the engineer of record, it's our duty to look for these things and to help out when challenging situations arise. All right, so just to add a little bit of additional motivation for the construction quality assurance piece, for the membranes, if there's a flaw in the installation, we could, in the worst case scenario, actually have a vapor intrusion condition into indoor air that may even cause exceedances of regulatory criteria. And when it comes to the venting systems, if there's a problem there, we might see diminished performance, meaning lower flow and less frequent sub-slab air exchanges. And if these flaws, if you will, compound, then they can, taken together, really compromise the effectiveness and the performance of a vapor mitigation system. All right, so just to provide some categories for the project examples that I'll be showing, these are the, if you will, categories or buckets that these examples, loosely speaking, fit in. So when it comes to membranes, we might see issues related to the original design. There might be challenges with the actual installation, and then there can be challenges that are related to, if you will, just the timing within the project, or timing in terms of during the year. For venting systems, there are also generally more just installation shortcomings. And then there are some unique challenges that arise during tenant improvements. So I'll touch on all of these areas. All right, so the first example that I have here is I'm calling it a design flaw, and that is some designers include in this case, it's shown in the detail as a 2-inch sand layer on top of the membrane. And I think many of us that have been at this for a long time might have included this type of a feature in our designs in years past. But the challenge with the sand layer is that it can obscure problems with the membrane. And so what can happen is the membrane is installed, it's perhaps smoke tested, everything looks good, and then that 2-inch sand layer is placed on top of the membrane, and now a puncture might occur or a tear, and you won't be able to see it because that sand layer is obscuring that. And I know there are cases where sometimes regulators want to see, as is shown in this detail, a monitoring probe to seemingly, verify that the membrane is functioning the way it should. But really, this approach really causes more problems than it solves. So in my experience, the better approach is to not use this, not incorporate this sand layer as a protection layer, but instead use the protection fabric or some other approach and just pour the concrete right on top of the membrane. And what we've seen, we've been called in by fellow consultants to help from time to time when they have some challenging situations. And recently we were approached by a fellow consultant where they had a problem with exceedances in indoor air of their contaminants of concern, and come to find out that the design engineer had used exactly this approach. They had a sand layer on top of the membrane, and our co-consultants very carefully drilled through the slab, were able to collect air samples from that sand layer. And what they found was that the air, if you will, in the sand layer had the same levels of contaminants as were present in soil gas. So really at that point, their membrane was not serving really any discernible function. And all we can surmise is that the membrane was compromised after that sand layer was poured on top of it. So some consultants still continue to incorporate this 2-inch sand layer. And what we've seen, again, is it just causes way more problems than it solves. And we're really encouraged to not put that sand layer there. All right, another example of an installation flaw, and this comes up with spray applied membranes from time to time. And this is an example of a project from many years ago. Installations are no longer done like this, but just to kind of make the point, the challenges of trying to spray a spray applied membrane on an uneven surface. In this case, the applicator was trying to spray on essentially the fabric that covered a drain board, and they had great difficulty with that. Ultimately, they did end up passing the smoke test, but they had to apply quite a bit of this material to get it to the point where they no longer had pinholes. We've also seen, for example, applicators, they run short of time and they try to do an installation on, after sundown, for example, and you just can't see very well. So, there are a variety of, if you will, suboptimal or poor conditions for membrane installation, and they can be unique to the type of membrane, of course, that's being installed. So just a thing to be aware of. You want to make sure you're installing the membrane under good light conditions on the right substrate. And the good thing about a spray applied type product is it's easy enough to fix, just respray. But again, care should be taken to apply on the correct type of substrate. The next example I have here is not sure if it was a design shortcoming or an installation shortcoming, maybe a combination of the two. Here, we were engaged on a site post-construction when the owner became frustrated with some of the aspects of the vapor mitigation system that they had installed for them. And what we found upon arrival was one of the challenges that they had was that there were a number of these through-slab sampling ports that were seemingly poorly constructed, and or the membrane hadn't been sealed around them properly. And again, after the fact, post-construction, it's impossible really to assess what exactly the problem is, but certainly the problem that our field staff were having is they had a very difficult time conducting the shut-in test that's required to then collect a whole air sample from these through-slab sampling locations. And you can see in the photo on the right, there's just an opening in the floor and the tubing is uncapped. So our staff did the best they could to seal off the locations. This is just one of half a dozen of these problematic sampling port locations. And of course, they capped the tubing, and then with that, they were able to proceed with the sampling. So this just illustrates that it's important to take care during installation of the membrane to make sure that you get a good seal around your sampling port, whether it's a commercial product like VaporPin, for example, or if it's just a sampling port that the engineer has designed themselves. Whatever the case may be, getting a good seal of the membrane around that sampling port is really key. And again, the way to verify that, in our opinion, is through smoke testing. All right, and this next example here is what I'm calling a timing challenge, which can result in a membrane really being subjected to very rough conditions, and where workers just don't take care of that membrane. Maybe it's just obliviousness, who knows? But whatever the case may be, this is not a sight that we like to see. And in this particular case, what happened is, and this can happen on a number of sites where for whatever reasons, there needs to be a leave out, what's called a leave out in the concrete pour. So you can see the concrete's been poured around this area, but they've not poured concrete in this particular spot, maybe because they're going to be installing some equipment afterwards. It can be a variety of reasons. So you could have these leave outs. And so it's of course disheartening to see this when you come back to the site some weeks or months later, but fortunately it's not impossible to fix. There are obvious holes and they need to patch those. In general, we would say conduct another smoke test, make sure the membrane is intact. But really the better approach is if these leave outs are absolutely necessary, then ask the contractor to put plywood over it or some other measure of protection just to make sure that that membrane doesn't get covered with debris and whatnot and be subjected to damage while it waits for the final rebar installation and concrete pour. And now switching gears a bit to the venting system installation, some challenges that we've seen. We design a lot of passive venting systems, at least for the California market. So our design details, I think, are quite clear in terms of what the riser height needs to be, that the riser needs to extend at least a minimum of a foot above any surrounding obstructions, such as a windscreen or an elevator, penthouse or equipment, solar panels, what have you. And so that the cap that's placed on that really is able to make contact with air, with the wind. And again, we try to make that very clear. It's spelled out in the detail, it's spelled out in the notes. And yet what will happen, has happened more than once, is we come to the site to take that last look, make sure everything is the way it should be, and we find something like this, where the riser does not extend above the windscreen, does not extend above the penthouse, but is completed such that it is fully protected from the wind. And so that really affects the functioning, certainly, of a passive venting system. This is a slightly older design where we used essentially a version of an attic fan. These days, we've gone to Venturi caps. So these are caps that don't have any moving parts, just so that we don't run afoul of the air district permitting process. So again, these are slightly older designs. They've been a little bit changed now, but the concept is the same. We want that riser to extend above these windscreens so that they can vent as fully as possible. And again, here the fix is very easy. Just have the plumbing contractor come back out and extend those risers. Another feature that we often incorporate into our designs are what we call perimeter inlet vents. And the purpose of the perimeter inlet vent is basically just to enhance the functioning of a passive venting system. And it allows fresh air to enter that sub-slab venting layer and enhance the sweeping motion towards the risers. And from time to time, regulators are concerned about reversal of flow. I've never seen that happen, but continues to be a concern for some. And in some cases, like for landfills, you certainly would not want to see that happen. So just to be on the safe side, design solution that we've come up with is to install what's called an inverted barrow balls. Barrow balls are a commercial product. Then there's the regular version, and there's what's called the inverted version. And so what the inverted barrow ball does is it allows fresh air to enter the sub-slab venting layer, but it does not allow gases or vapors to escape through the piping here. So that is the design intent. And again, arrive at the site for a final site visit. And what we see is the photo on the left, the barrow ball has been installed incorrectly. And basically, this inlet vent is completely shut off. It's not performing its intended function. So the photo on the right shows the corrected version, and you can see the little air holes there. So that's what allows the air to enter the sub-slab venting layer. So when we first conducted a performance monitoring event with the barrel balls closed, we were a bit dismayed to see that we were getting only one air exchange per day in that sub-slab venting layer. And then after the barrel balls were corrected, we found that our flow rate doubled or better. So this is a type of detail that can be easy enough for field staff to overlook. So it's important that they understand how these need to be installed. Another example that we've seen multiple times is a failure of utility pipe hangers. And I've been involved in 3 projects where problems have arisen after building completion with specifically the sanitary sewer piping underneath the structure. And so the fix, unfortunately, is extremely expensive and time consuming. It essentially involves tunneling underneath the completed structure to find the damaged sewer pipe locations and address them. The good news for us has been in all of these cases that we have found that the VMS membrane is in good condition. It has adhered to the underside of the slab exactly as we had intended it to. Our vent piping is intact, and it was hung properly per our details, but unfortunately in this case the sanitary piping did need repairs, and the red arrow there points to a clevis type hanger, and then those get essentially drilled into the underside of the slab, and then the membrane needs some patching around those locations. And so here what we tell our staff is if our vent system piping requires hangers, then if you're not seeing hangers for other plumbing, you might want to mention that to the project superintendent, or at least bring it up with your project manager to see if it's something that needs to be brought to the attention of the construction crew. And again, we've seen this more than once over the years, so hopefully don't see it again, but it is a problem that can and does come up. This next example switches gears just a little bit now to conduit seals. This was a project that was a redevelopment on top of a closed municipal solid waste landfill that was still generating some amount of landfill gas, which of course includes methane. And at least per the California regulations, these structures must be equipped with a gas detection system that can alert occupants to an exceedance of methane in indoor air before it approaches explosive levels. So in this particular case, the gas detection system was picking up methane in the electrical room, and the design team was called out to the site. And what we ultimately determined was that there was a utility vault right outside that electrical room, and the way it was constructed, landfill gas was able to seep into the utility vault, which would not be the end of the world. But unfortunately, in this case, the conduit that led from the utility vault into the electrical room had not been sealed. There was more than one conduit. And so the contractor needed to go back in and seal all of those conduits. And it took quite a bit of effort to get it to the point where that gas detection sensor stopped sending out an alarm. So we try to emphasize, not just for landfill projects, but also brownfield projects, the importance of finding these where the utilities penetrate the building envelope or through the slab, and make sure that those are properly sealed. Another example of a piping challenge, our design sometimes entails having a different vapor mitigation system piping if you will, systems crisscross each other. We try to avoid these crossings, but at times they're just unavoidable to achieve the objectives of the design. So in this particular case, we had a passive piping network and then sort of a backup or contingency active piping network. So two completely separate, meaning like redundant piping networks. This was for a landfill redevelopment project. And the intent here is just to allow these networks to cross over each other as needed. And our staff went out there to conduct a construction observation. And unfortunately, I was not able to locate a photograph of the incorrect installation, but the photo on the left shows just what that piece looks like. It's called a cross. And so instead of these piping systems crossing over each other, they were connected to each other. And had that error not been found, what would have happened in this particular case is we would have had a fairly significant dead zone in the venting layer underneath the structure. So just another example of why it's really imperative to have the design engineer look at the installation of all of these seemingly small things. So then the photo on the right shows the corrected condition. You can see one pipe crosses over the other. You can see the hanger there too. You can see that the membrane is being wrapped around the piping to protect it. But yeah, so the photo on the right is what it should have looked like from the beginning. And then there are adverse weather events that we sometimes need to contend with. And this is an example of a membrane that relies upon a bentonite layer. And there are several membrane products that incorporate this bentonite layer. And what happened here was there was a significant overnight rain event. The membrane was in the process of being installed, and so upon contact with water, the bentonite hydrates, and that essentially renders that piece of membrane sort of damaged. It won't be able to perform its function when put into service. So the fix was, a little bit time consuming, and you hate to see it have to be done, but it wasn't that difficult to do. Just essentially cut out the damaged pieces of membrane and replace them with new membrane. And I just want to note that, the various membrane products can be prone to other types of weather-related damage. So it's just a thing to be aware of, to make your field staff aware of. Here's another example, similar or perhaps the same project, where I believe what happened here is, again, some late season rains, and the water was able to pond in these pockets. You can see the concrete has been partially poured, but there are other areas where the work is still in progress. And in this particular case, a little bit of that bentonite did hydrate or leak out. And so the fix there, which was cleared with the membrane manufacturer, was just to install new membrane on those seams. And you can see that in the photo to the right. So again, just something to be aware of. Different membrane types could be prone to different types of damage or compromise during different types of weather events. So something just to be aware of and to alert your field people to. And then we get to post-construction tenant improvements. So these tenant improvements might occur before the building is occupied, but after the main vapor mitigation system has been installed. Construction is still in progress, but now a tenant has signed on and they want to make their certain improvements to the space. And unfortunately, what can happen and does happen from time to time, they bring in their own construction crew who are not alerted to the presence of the sub-slab vapor mitigation system. And you see, unfortunate occurrences such as those shown in these photos. The one on the left, basically, they just demoed the slab, and with that shredded the membrane, and certainly did not leave the necessary tie-in, in this case, the tie-in flap around the edges for new membrane. In other instances, they might just core through a slab and not take care of that membrane, or they might, during their trenching, actually damage the vent piping. All of these things have occurred and unfortunately continue to occur. And so the good news is it's pretty easy to see when there's a problem, but you hate to see it, after the fact when the damage has literally been done. So what we try to do is make, especially new owners, if there's a change in ownership, aware that there's a sub-slab venting system in place and that care needs to be taken to not unduly damage the membrane or to damage the venting system. So we'll prepare a VMS repair plan and provide construction observation services during that phase of the TIs. And this next example is a very unique example. I've only seen this happen once, but get a call from the contractor, get some photos, and there's this cementitious slurry inside of the venting pipe. And it took a little, sleuthing to figure out what the problem was. What we ultimately figured out was that they had used copious amounts of water during saw cutting. And you can see that in the open trench in the photo on the left. There's just pooled water in the excavation. And so the guidance after that was just to, please cut down on the amount of water being used. And we did need to make sure that they cleaned out the vent piping and that it was restored to its proper functioning before they proceeded with the work and closed up these trenches. All right, so to just wrap things up here, just some tips here, some parting thoughts. It is important to have that kickoff meeting for some of the membrane products available. That is actually spelled out in the specification. But even if it's not, it's something that we want to see happen, is this kickoff meeting that includes the general contractor, the piping installer, the membrane installer. Sometimes they're the same subcontractor and sometimes not. Preferably also a representative from the membrane manufacturer, the rebar and concrete subcontractors, the design engineer, and if possible, the owner. The presence of the owner does lend a certain amount of importance to the meeting that might not otherwise be there. So we like to see the owner present. Then, of course, a strong construction quality assurance program. Some regulators require vapor mitigation CQA plan, some don't, but in any case, we recommend having one and then making sure that that's enforced, that the general contractor, the membrane installer, the piping installer, they all understand what is required. And then we, as the design engineer, conduct regular site visits to provide construction observation services. We witness smoke testing. We conduct thickness measurements especially for spray applied membranes. That's important. So whatever is needed, we do and make sure we cover every square foot, if you will, of the application. And then also just alert staff who conduct the observations to just really look very carefully, look around and just look for damage. Sometimes, again, for a spray applied product, they might apply too much product and cause certain problems, or again, weather damage. If there's been welding done above and the membrane's exposed, there could be slag or nails, what have you, that fall on the membrane and potentially damage it. So ask staff to really look around, look carefully, walk the entire portion of the membrane that's just been installed and look for any signs of damage or potential damage. And we recommend preparing a checklist for field staff so they kind of have a system for going through everything and hopefully avoid overlooking certain things. And I think one of the biggest challenges is when a change in ownership occurs. So you lose that institutional knowledge. And sometimes what we've seen is that the new owner or two owners later, they don't even know that they have a gas or vapor mitigation system underneath their building. So just something for design engineers to be aware of. And perhaps we need to do a better job of incorporating information regarding tenant improvements into our completion reports and into our OM&M plans. In some cases, regulators provide a fair amount of tracking and follow-up. I've seen that particularly for landfill redevelopment sites, but there are so many brownfield redevelopment projects that it's virtually impossible for regulators to track them. So one thing I've seen that's come to my attention recently is that there are commercial institutional controls tracking services. So that might be something that someone, might want to consider or at least look into. All right, and that concludes my presentation. And at this point, I'll hand it over to Nick Mjolsness.
Thank you, Sigrida, for that excellent overview of construction quality control. I'm Nick Mjolsness, and my focus today is on CQA and what it means for land science systems, why it matters for performance and compliance, and also how to implement it effectively. So we'll start with below grade barriers and then finish with retrocoat for existing buildings. Here's a quick roadmap of the presentation. This should only take about 10 to 15 minutes, but as mentioned, we're going to start with land sciences required CQA elements for below grade vapor intrusion mitigation systems. We'll spend some more time on retrocoat CQA for existing buildings, what to test, how to prepare, and how to verify. And then we'll finish with some key takeaways and resources you can apply immediately. So for below grade systems like TerraShield, NitroSeal, and MonoShield, CQA is non-negotiable because it directly impacts barrier integrity and long-term liability. Our requirements include certified applicators, so only trained and certified installers can apply these systems. This ensures correct spray application, seam detailing, and adherence to our specifications. I mean, they do this so often, they do so many applications of our systems that they really know what to watch out for. Third-party inspector verification. So we actually offer training on our website for third-party certifications. Independent oversight is critical. So inspectors document substrate conditions, application thickness, seam integrity, and any corrective actions in an inspection log. And then ideally manufacture review and pre-construction meeting attendance. So before mobilization, as often as we can, we prefer to review project plans just to confirm system compatibility, align stakeholders on sequencing, QA/QC protocols, warranty requirements, that sort of thing. Also thickness and integrity verification. So the spray applied core, it's verified using wet mill gauges or calipers, and seams and penetrations undergo smoke testing to confirm continuity. So smoke testing really helps to identify pinholes at seams and penetrations. So, if they run a smoke test, you can see on a photo on the right, that was a smoke test that was being performed at a project at the Sacramento Rail Yards. But if a pinhole leak is identified, the installer will mark the location, continue with the smoke testing, mark any additional locations, and then they'll come back and apply additional material. So after the additional material is applied, a second smoke test is performed just to ensure there's no pinhole leaks. And then of course, the final pre-pour inspection after trade, traffic, and reinforcement is placed. A visual inspection ensures the barrier is intact before concrete placement. So as mentioned, I'm going to spend a little bit more time on retrocoat. So retrocoats are epoxy-based vapor barrier for existing slabs. Unlike below grade systems, retrocoats installed in occupied or operational environments, so precision and verification are critical. The CQA process focuses on 3 pillars, and those are pre-installation assessment, surface preparation, and installation verification. Moisture testing standards, it's really the most important, I think, aspect of determining what kind of primer you're going to use. So I've included a visual on the right. Typically, calcium chloride tests are done. So that's ASTM F1869. And then in situ RH tests can also be performed, and they give kind of a more comprehensive overview of the moisture content in the slab. But both of these tests determine if elevated moisture vapor emission rates require primer MV instead of standard primer. So skipping this step, you risk not knowing the primer you need to use, and it could lead to adhesion failure. So I'll talk some more about surface prep, but here's a couple of more photos of what the calcium chloride test looks like. These are left in place for 60 to 72 hours. And the typical procedure is to install one of these every 1,000 square feet. So the other key aspect of pre-installation concrete prep is the actual surface preparation. I've included a visual here. This is an industry standard. CSP stands for concrete surface profile. And typically we will require a CSP of 3 to 4, depending on which primer we are using. And this is really equally critical. Here's the photo I was looking for. This shows the shot blasting. So in this case, they were doing a standard CSP of 3, and a benefit with this, it also kind of removes any paint or coating that's already present on the slab. And then so installation verification. So we require 26 to 40 mils total for retrocoat, depending on the primer that's being used. Wet mill gauges can be used during the application, but we also do material yield tracking to confirm coverage, because retrocoat is 100% solid. So we can get a really good idea of the actual yield rate by comparing the square footage of the application to the amount of product that's going down. So this isn't listed here, but it's important to document any readings that are done in a QA/QC log. I think Sigrida mentioned that as well. Documentation is key. And so I wanted to show a quick kind of visual process, what the typical installation for retrocoat looks like. Here you see, typical concrete repair. I mean, these are existing buildings, so you're going to run into cracks. And then depending on the moisture levels present in the slab, typically either a standard primer or moisture mitigating primer MV is used. But in other scenarios, we have other primer options as well. So retrocoat installation is performed in 2 lifts to achieve the required thickness. So each step is verified. You can see here they pour it out and they use a slotted squeegee to spread the retrocoat. And typically these will be notched squeegees, so they can set the thickness to 10 or 20 mils, and then they know how much is being put down on the slab. And the whole process, including quality control, typically takes about 2 to 3 days for the application, and then 1 to 2 days for the prep work. So just touching on key takeaways, I know this was quick, but CQA is really going to be the performance lever. It ensures compliance, project warranties, protects liability. For below grade barriers, certified installers, third-party inspection, thickness verification, these are all things that are extremely important. And you can see for retrocoat, we kind of follow a similar process. Retrocoat is also installed by certified applicators, so they know what they're doing, and they're experts in the field. But also documentation, just to hit on documentation again, inspection logs, photos, checklists, these are all essential to hang on to, because even if proper installation occurred or inspection occurred and there isn't a log, it didn't do much. So that's what I have. Any questions?
All right. Yes. Thank you, Nick. As you said, that's going to conclude the formal section of our presentation. So now we'd like to shift into the question and answer portion of the webcast. Before we do that, just a couple quick reminders. First, we're going to be sending out a brief survey after the webinar. We really appreciate your feedback, so please take a minute to let us know how we did. And also, you will receive an email with the recording as soon as it is available. All right, so let's circle back to the questions here. And the first question is for Sigrida. Sigrida, the question is, have you ever had a client or regulator require VMS CQA to be performed by a third party? And so what was that like?
Yes, I would say there's at least one occasion, one project that I can recall where a client wanted a third-party inspector, if you will, to perform the construction observation instead of us. And it was challenging because the inspector, they're not a design professional, or they weren't in that particular case. and they, they kind of go by the book, but at the same time, they don't really understand what's okay, like what's acceptable versus what's really a no-go. So, for example, what we've seen happen is where, let's say, the plumber, whoever's installing the vent piping, they run into some sort of let's say, a conflict with something, and they have to reroute the pipe, and instead of bringing us in, the design professional, to do the reroute, they just kind of DIY it, and in doing so, they kind of compromised. I mean, the system still works, but it wasn't the best solution. We would have done it differently. So, if the design professional is really the best person to make these calls, including in the field, as to, what's appropriate, what's okay, and what could be done better, or what's really not acceptable. So if one doesn't have that background, I think the wrong call can be made, or it's almost like an excessive, perhaps over enforcement, perhaps under enforcement. There can just be some real misses. So we recommend against it. We prefer to see the design engineer provide the construction quality assurance function, be that us or someone else. We've been approached at times by clients who they've had someone else be the design professional and want us to do the construction CQA, and we prefer to not do that. We'd prefer, again, even if it's, we have this opportunity, we'd rather forego that opportunity and really encourage the client to use the design professional to provide those services.
All right, thank you, Sigrida. So here's one for Nick. And so Nick, kind of related to what Sigrida was talking about third-party inspection. What is the land science inspector training, and where can attendees of this webinar access the QA/QC checklist that you brought up there?
Yeah, so great question. The checklist, I think we're going to share it after the webinar. It's also available on request, so feel free to reach out to me and I can provide it to you. It's also listed in our specifications and submittals. And as far as the inspector training is available through our inspector program on the website. So we'd be happy to send out a link for that too and get anybody set up that would like to enroll in that training.
All right, continuing on here. Let's see. So here is another question for Sigrida. And it is, are there any industry standards or guidelines for vapor mitigation system CQA?
Yeah, so interestingly enough, at least to the extent that I'm aware, there's plenty of regulatory guidance when it comes to gas or vapor mitigation system design, but not so much when it comes to construction quality assurance. And fortunately for the industry, there are at least a couple of organizations that have made, I think, great strides in addressing that. One of them being ITRC, and the other being AVIP, the Association of Vapor Intrusion Professionals. Both of these organizations have tackled the CQA question, if you will. And I know that the Association of Vapor Intrusion Professionals, if they haven't already, they will soon be coming out with essentially guidelines or checklists for construction quality assurance for gas and vapor mitigation systems. So there are resources available that are certainly helpful. They're not intended to be the be all and end all, but they're very, very, very helpful. And I encourage folks to avail themselves of those materials.
Okay, thank you, Sigrida. So here's another question for Nick. Nick, the question is, what field checks are non-negotiable for below-grade systems?
Yeah, it's another great question. So thickness verification, smoke testing, visual pre-pour inspections. For retro coat, it's the surface profile verification of CSP of 3 or 4, but also the moisture testing. So in most cases, calcium chloride, and that's something we require, and it really helps to ensure barrier longevity.
Okay, thank you, Nick. So here is a question for Sigrida. Sigrida, the question is, in your experience, what's the most commonly encountered construction flaw for vapor mitigation systems, and how have you tried to mitigate that?
I would say, in my experience, the biggest challenge is just less than perfect, if you will, membrane installation. Again, not for people doing their best and really trying to do a solid membrane installation. There just are challenging conditions where it's just difficult to get that perfect seal. Let's say at a foundation element or around a penetration. So it's even when people are really working very hard to do a great installation, there are just challenges that are encountered. And so those are, generally speaking, the best way to do that check is with a smoke test. In my experience, more and more membrane manufacturers are actually requiring the smoke test as part of their specification. Sometimes it still shows up as optional, but we always put it in our design documents that the smoke test is required, because that just seems to be the best way to make sure that we do get that nice seal everywhere.
Okay, thank you, Sigrida. So here's a question for Nick. Nick, the question is, what documentation is critical for extended warranty eligibility?
So good question for extended warranty acceptance. We require inspection field report, a site data package, so a soils report or equivalent, in addition to inspection log to ensure the smoke testing and coupon sampling was done. And we also want to review the design as well prior to application.
All right, thanks, Nick. So here's another question for Sigrida. And Sigrida, the question is, have you ever had a regulator require a second smoke test, for example, after rebar placement, but before the concrete pour? And so if that did occur, then do you think they're a good idea or are they just a waste of time?
Yeah, so we've had, in my experience anyway, a couple of projects where the regulator has wanted a what they call a secondary smoke test. And I think the answer to that is it a little bit depends. It can, in some cases, require some modifications to the design so that smoke can be, if you will, the smoke testing equipment can be attached to or fed into the piping system underneath the membrane. That may seem or sound simple enough, but it's not always simple, especially if the membrane is installed in batches, if you will, and if there are foundation elements in the way or not present, just sort of depending. So yeah, it may need to be designed for during the design process. So that's just additional effort that's required. And the other piece is it also just it depends too. During construction, sometimes the membrane can actually be subjected to additional damage during that secondary smoke test, because the membrane usually at that point is completed and now folks are walking across it, carrying equipment across it. It's just more traffic on top of the membrane. And generally the regulators want to not see, for example, the protection course fabric on top of the spray applied. They want to have that spray applied layer exposed. So then that's opens damage. So it just really depends. And where we see real challenges with that, we'll go back to the membrane manufacturer and ask them to to please get involved and have a conversation with that regulator to see what's driving their concern and how we might be able to address those through means other than a secondary smoke test. But sometimes, yeah, they want to see it, and you just have to do your best to accommodate that.
Okay, thank you, Sigrida. So here's another question for Nick. Nick, what's the most common CQA mistake you see in the field, and how do we prevent that?
Yeah, I mean, so mistakes happen in the real world, and we try to be involved as much as possible so that we can avoid mistakes. But from time to time, I've seen moisture testing either not performed to specification or, and this is for retro coat, the surface prep not being done the way it should be, depending on what's happening on site. So this is all part of why we really require retro coat, and our other systems are installed by certified and trained applicators. This way they can, they know what the key potential mistakes are, and they've been doing it so often that it's kind of a habit for them. They know what to do and how to do it.
Okay, thanks, Nick. So let's see here. This is another question for Sigrida. So do clients ever choose to have a vapor mitigation system designed and installed, even if the site impacts did not exceed regulatory criteria? And so if so, have you provided a membrane only or venting only design, or do you only go with a full membrane and venting design?
So that's a little more of a design question, but yeah, we've definitely had situations where the site conditions do not really call for a vapor or gas mitigation system, but the client has sufficient concerns that they still want to see, like they put it, they still want to see something. And we'll have a conversation with them, but sometimes they say, well, we're going to put down a capillary break type of membrane anyway, and so what we'd like to do is just to beef up that membrane so that it's resistant to, let's say, VOCs, for example, because site conditions could change, and we just want to make sure our building and its occupants are protected. So in those cases, yeah, we'll just go with an engineered membrane product, something a little more robust than your typical 10, 15 mil, visqueen type of product. In other cases, I think where the slab is, for example, quite robust, there's a project that we currently have in design where we're just going to put in a venting only approach, just because there's a little bit of benzene at this particular site, and we have some concerns about that, and the regulator is a little bit concerned about that, and it's not a big deal. We could say, well, on average, the risk is acceptable, but we've decided, and the client has agreed, that just putting a venting system inside the permeable layer is probably wise, and then that way we avoid any potential complications, down the road post-construction. So we've done it both ways. And I would say, rarely will the client really want a full-blown vapor mitigation system when one is not needed. So yeah, generally we'll go either venting only or membrane only, just again, depending on the situation.
All right, thank you very much, Sigrida. So that is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you'd like to learn more about services from Langan, please visit langan.com. If you'd like to learn more about vapor intrusion mitigation technologies from Land Science, please visit landsciencetech.com. Thanks again very much to Dr. Sigrida Reinis and Nick Mjolsness, and thanks to everyone who could join us. Have a great day.